Thank you very much, Maura, and hello to our NAA friends and colleagues, and greetings from Montana. I'm Steve Shelley, co-presenting today with Justin Crotteau. Our other co-authors are Mary Manning, Kurt Wetstein, Bob Keene, and John Byrne, all with the U.S. Forest Service in Montana. The project leaders are Mary and Justin. Our presentation today is about an important research natural area on the Lolo National Forest in western Montana, the ecologically unique high elevation forest that occurs there, and a new cooperative project with citizen scientists to monitor the effects of a wildfire that affected the RNA and this forest stand in 2017. For our presentation, we'll provide some brief background on the Forest Service Research Natural Area Program, the Carlton Ridge RNA in western Montana, and the importance of the Alpine larch stand that occurs there. Then we'll discuss the effects of the Lolo Peak fire, a large lightning ignited fire that occurred in 2017 and burned portions of the RNA. Lastly, we'll describe a post-fire monitoring study begun this year with the Friends of Lolo Peak, a conservation group based in Missoula that incorporates citizen science to follow the eventual recovery of this iconic forest stand. The first RNA on national forest lands was established in 1927 in Arizona. These protected areas comprise a national network of protected areas established to represent the range of vegetation types present on these lands. RNAs are designated in perpetuity for research, education, and the conservation of biological diversity. To date, 533 RNAs have been approximately 600,000 acres. This map illustrates the distribution of these natural areas in the US and Puerto Rico. Zooming in now on Region 1 of the US Forest Service, which extends from northeastern Washington all the way over to southeastern North Dakota. This map shows the location of the established RNAs in the northern Rocky Mountains and the northern Great Plains. The blue star near Missoula in western Montana is the location of the Carlton Ridge RNA where our study is located. The National Forest Service policy regarding RNAs includes 8 objectives for this protected area network. Of special relevance to our project are the last 2 regarding the importance of these areas for the study of natural ecological processes. In this case, the post-fire recovery of a high elevation forest, and as otherwise undisturbed baseline areas for measuring ecological changes occurring over time. These objectives are particularly important given the changing climatic conditions and other broad-scale environmental changes that are occurring, such as those caused by non-native invasive weeds and pathogens. The tree species of interest in the Carlton Ridge RNA is Larix lyallii, or Alpine larch, or from a purist's common name standpoint, subalpine larch, since technically trees do not grow in alpine habitats. It is one of 3 deciduous conifers occurring in North America, and the only one to occur at high elevations. This distribution map indicates the relatively small geographic distribution of the species. Within this range, the species occurs at the upper tree line, most frequently from about 7,000 to 9,000 feet on very rocky slopes. The red circle indicates the location of the Carlton Ridge RNA. This Google Earth photo encompasses the top of Carlton Ridge, lying at elevations up to 8,200 feet, in the Bitterroot Mountains of west central Montana. The forest type of interest here is dominated by alpine larch. This stand is distinguishable as the slightly lighter green area along the ridgeline in the middle of the photo, with small openings scattered throughout. The darker green forest below the alpine larch in the bottom of the photo primarily consisted of lodgepole pine and subalpine fir. I say consisted of in the past tense because these forests were largely consumed by the Lolo Peak fire in 2017 that we'll discuss further in a moment. On the ground, this beautiful stand of alpine larch is an open grown forest with an understory of mountain heather, the dark green patches in the photo, and wood rush, the tan colored graminoid species. This site is in a zone of deep winter snowpack. A number of trees in this stand have been cored for dendrochronology studies, and despite their rather small diameters, the trees have an average age of 350 or more years. So this is a very unique, high elevation, old growth forest. The other very unique ecological feature of this forest is the deep soil environment where the trees occur. Again, the much more typical habitat for alpine larch is very rocky and well drained, but in this case, a climax stand that is much more uniform in stature and density is formed on these deep soils. The top of Carlton Ridge escaped glaciation, which enabled this deep soil mantle to form over time. And along with the deep snow deposition along the ridge has allowed for the species to dominate in this case. Only one other area for alpine larch in southern Canada has been observed with similar characteristics. Everything changed for Carlton Ridge in 2017, however. A lightning fire that started in midsummer of that year and which did not really expand much initially, finally reached the extremely dense lodgepole pine and subalpine fir forests on the north face of the ridge. These forests had not seen fire for over 90 years, and the combination of high fuel loads and a wind event in mid-August resulted in a huge explosive run for the fire. This view from Missoula shows the giant smoke plume that occurred when these stands finally burned. It was really only a matter of time before this kind of expansive wildfire occurred here. This remotely sensed map showing soil burn severity clearly indicates the areas with the highest impacts from the fire. The white oval marks the area where Carlton Ridge RNA and the study plots that Justin will describe are located. The large red polygon just above the oval indicates where the fire really exploded and moved from west to east across the north face of the ridge. And the margin of the burned area where the fire affected the larch stand to varying degrees is also within the white oval. This photo is a view of the north face of Carlton Ridge from 2 summers ago. So 1 year post-fire. The RNA boundary is shown by the white line. The high wind event basically blew the fire straight from west to east, or from right to left in this photo, through the pine fir forest, and did not completely consume the alpine larches on the ridgeline, as evidenced by the dark yellow foliage color near the top. And this, I must say, was really good news for folks around Missoula. This stand is actually visible in late September from town, and everyone was quite concerned that they had been lost in the fire. But the good news is that the trees are still present, and many of them are still surviving and changing to their beautiful yellow color in the fall. All right, now Justin will describe some of the fire effects in more detail and the collaborative study that is being initiated. Thank you.
Great, thanks, Steve. Okay, so as Steve mentioned, my name is Justin, and I'm going to walk us through first some of the on-site photos as we walk up through this fire. Here's a nice example of some of that lodgepole pine forest cover type that Steve was describing. This is a stand going up to the ridge that's predominantly lodgepole pine and subalpine fir, and as you can tell, it was hit by some stand replacing fire, some high severity fire. This is the forest cover type that was, for the most part, hit the hardest by the fire in terms of severity. But what we see here are some relic beargrass clumps that whose underground parts survived the fire and have resprouted since. On our next photo, this is as we climb in elevation. This is on the edge of where that lodgepole pine and subalpine fir cover type transitions to the alpine fir, the subalpine larch forest cover type. You can see here that the severity is still very high, and that there's not even any beargrass regenerating here. There's actually more rock exposed on the ground, and we're starting to see some erosion here, and that's a big problem. Next, there we go. Next, some of the, I advanced too many, sorry. There are other portions, as you might guess, in a big fire, that you'll either completely or partially escape fire. And so here's an example of an area that received very little of that fire, and we see residual white bark pine and alpine larch and some subalpine fir and some of the ground cover of the mountain heather and wood rush. Next, here is an example where you could still see needles on the tree. That tells you that this is not, that at least parts of this forest did not burn with high severity crown fire necessarily, but just fire that might have crept along the ground, and these trees succumb to heat. They have thin barked, these are thin bark species. White bark pine, alpine larch, and subalpine fir, and lodgepole pine all have very thin bark, and a little bit of fire at the bottom around the base can kill the cambium and scorch the tree up higher. And then, as we progress through this area, there are more moderate severity areas. You can see both live and dead trees here in this photo, white bark pine and the alpine larch, and you can see some ground cover has remained while others were burned up. There are also places along the ridge where there are really abrupt transitions, and between high severity, like we see on the left of this photo, and low severity or almost unburned, maybe unburned on the right. And so these are really interesting features within this forest cover type that demonstrate the complex mosaic of the fire effects that we had here in this study, or in the study site. Furthermore, there are also these little glades of regeneration. There's a lot of alpine larch here that we've dated some of the maybe around 4-foot trees that have been about 90 years old. So they've been here for a while. You can also see some subalpine fir here. But perhaps because of the high foliar moisture content of these areas, they evaded the fire, which is really interesting. Next, here, as we enter into the actual legal definition of the research natural area, on the southwest corner, we do have some of the original stand that was intact, original alpine larch stand that we see here intact. You can see It's in many places it's kind of park-like, open, and there's some big relic wood on the ground too. So back to our idea of our title, we're talking about shared stewardship opportunities at the Carlton Ridge RNA. The Forest Service has unveiled a shared stewardship strategy, and one of the key, I'll just read this second quotation here from the Forest Service's shared stewardship documents. Our vision for the investment strategy is based on continuous learning, as well as on shared stewardship across broad landscapes. It's about working together in an integrated way to make decisions and take action on the land. So a lot of the formal shared stewardship strategy of the Forest Service is working together across a collaboration about fire. And as you see from this quote, it's about learning too, and trying to decide how to manage our landscapes better together. So typically the shared stewardship agreements have been with states. We're wondering if, well, maybe shared stewardship can include volunteer groups as well. And so as Steve mentioned, the Friends of the Lolo Peak group they're the volunteer conservation group that approached the Forest Service and actually requested for involvement in some scientific process on the RNA, which is a very special area outside of Missoula, Montana, and ecologically as well. So their role is developing this partnership and assisting with us, where we represent the National Forest Systems, Lolo National Forest. We represent the Region 1 of the National Forest Systems, and we represent the Research and Development branch of the Forest Service. Now we're all partnered together with the Friends of Lolo Peak group to try to ask a question that is meaningful for the National Forest Systems and for the science group, the citizen group. And so our primary question has become, what is the effect of fire severity on this Alpine larch community in terms of cover, composition, and regeneration abundance? So we work together with them on that, and we're working together with them on data collection. And we thought a number of times this summer that this was going to work, and that we were going, well, it's going to work, but that we were going to be able to do data collection. But there have been a number of weather and logistical constraints that have delayed our initial plot establishment. Just as you might imagine, trying to hike up with manage groups of people going up into the woods at high elevation, which is threatened by thunderstorms and snow and all that stuff. It's just exciting. Anyway, let's see if I can go to the next slide here. There we go. As we discussed the different types of forest cover types here already, that had to take part or play a role in the design of this study to answer the question about fire severity on forest cover type. And so down in the south end of, so I'm showing you the research natural area and an adjacent area that has been proposed to be added to the RNA. And here you can see on the southwest end some subalpine larch stand in that light blue-green color. The purple-pink color is lodgepole pine cover type. And so we stratified by these forest cover types and by adjacency to a trail, so that way there's easy access for our volunteer conservation group to help out with our scientific process. So we stratified by cover type and adjacency to a trail within half a mile of the trail, and also by burn severity. And for burn severity, we use the Forest Service's ravage assessment. That's an assessment where they use satellite imagery before and after the fire to create a mosaic of burn severity estimates on the landscape. This is like one of the things that they develop. They do the preliminary analysis of like the composite burn index and so on. But we used one of their products that references basal area mortality. And so we created 3 different classes using their product, where there's a 0 to 10% mortality. So there's a little bit just barely any mortality in green on the bottom map, and then a big wide swath of moderate severity between 10 and 75% mortality, and then that's in yellow, and then in red 75 to 100% mortality. And what we see here on this map down in the bottom, there's a lot of high severity, but you can also see patches of yellow and green, patches of moderate and low severity. And so we created 18 experimental units, which was a result of the two different forest cover types, subalpine larch and lodgepole pine cover type, 3 different severity classes, and then replications within that. And so that's what, if you can see, we have little black dots that signify our sampling points within this research area. So since we are working together with a citizen group, it's very important for us to try to make this easier for them to monitor, and for us to monitor with them. And so we created a nested permanent plot structure. We're pounding in rebar and putting on nice fancy caps that show which plot number they're at, and using high visibility stakes in order to demarcate plot locations. These are nested. This is a nested plot structure where we'll be looking at the overstory above, and then tree regeneration, and ground cover and life form cover in nested plots. And so we have this network of 13, or of one big 24 meter by 24 plot with 13 different 4 meter by 4 meter subplots for tree regeneration, and little micro subplots within that for ground cover and life form. And the point of having all these little micro plots and small tree regeneration plots is because we thought that just making smaller areas for our volunteer workforce to look at will increase increase our confidence and their confidence in the tallies that they're creating. Now, they're not actually going to be doing the life form and ground cover. We'll be doing that part, but they have expressed interest in doing the tree regeneration. And so I'll just cover that just a little bit more. This is my just about last slide here. So we're trying to make this easy for the group by making it easy to make measurements. And so we've created these easy to use gauges for counting, especially the saplings and the seedlings. So we have seedlings that are less than 4.5 feet in diameter, or 4.5 feet tall. And we're equipping our volunteers with these height class poles that you see on the bottom left of this picture, where we have 3 different seedling classes that they can easily bend seedlings into. And likewise for saplings, for trees that are taller than 4.5 feet, we've created diameter gauges, easy go no go gauges, where they can bin sapling diameters into up to 5 centimeter class and an up to 10 centimeter class to make easy calls on the demographics of trees in this study. And so that's what we're doing, and then that's how we're trying to accommodate our workforce and work together as a team to develop science that's useful for both the national forest systems in assessing post-fire response in this more rare community type, and getting our citizens involved and engaged in a way that's both powerful for us and creates good synergies, and I think is going to be beneficial for both the ecosystem and our management in the long run. So thanks again. Thank you for bearing with us through these virtual presentations, and thank you for listening and your interest. And if you have more questions, well, I'm sure you'll be able to find us online, but just look for Forest Service employees Mary Manning and Justin Crotteau, and Steve is a little bit harder to get in touch with since he's retired now, but we'll find a way. So thank you so much.